Hi, Jason here from Swell School. We're now at part 2 of interactions. The chapter is titled The Transfer of Heat Energy and Its Effects. So why should we study this? I've highlighted here the official reason according to the syllabus. Overall, studying and understanding heat energy transfer can be a little obscure and abstract. However, it's actually really crucial for a wide range of practical applications. It can help us solve a lot of real-world problems. So, turning on that aircon, keeping us cool during hot days, or keeping us warm when it's freezing cold outside. How do we power our homes? How do we move our vehicles? How do we create new technologies that improve our lives? Not only for us, but for many people living currently in the developing world. At the same time, protecting the environment. If you have a deep understanding of heat energy transfer, these problems can then be easier to tackle. In addition, understanding heat energy transfer can provide many opportunities for you guys when you graduate in future and are looking at a career. Many industries and research topics delve into this topic. So whether you want to be an engineer in the future, a scientist, or just, like for what studying science is about, right? It's just helping you to get more context about the world around you, to gain an interest and an understanding about how the world works. Studying heat energy transfer is one of the real foundational topics that you can spend your time on. So I hope that that's helped with whetting your appetite. So now, what will you be expected to learn at school? Here are a few of the points that the syllabus requires of you guys and what your teachers will be looking to teach you. I've selected a few pretty cool videos. This one, check it out. Absolute Zero talks about what does 0 Kelvin actually mean. Kelvin is the temperature, SI unit for temperature, as compared to Celsius or Fahrenheit, that is more commonly used. So have a look at that video. It should leave a deep impression on what Kelvin is and what 0 Kelvin is. Next point, describe some effects and applications of expansion and contraction in everyday life. Yeah, this video here goes through thermal expansion and what are the effects of expanding matter when the temperature goes up. Also a pretty cool video. This one talks about how different objects, gases, liquids, solids expand when heated. Yeah, so please go through the videos that I've chosen. They're all interesting, so please don't skip them, okay? I try my best to make sure that only interesting videos make the cut. All right, this next one talks about the differences between conduction, convection, radiation, and overall heat transfer through those three different forms. This one here is another video kind of similar with a different style. So watch both and you have an even deeper understanding. Okay. The syllabus would also like you to understand that the rate of heat, energy loss, or gain by a certain body through radiation is affected by the color and texture of the surface and also the temperature of the surface. So I think for this point, check out your textbooks. Then your teacher will go through this as well. So When a surface is rough versus a surface is smooth, which one absorbs heat better? When a surface is black versus a white surface, which one absorbs and loses heat better? So give you a clue, a black car heats up a lot faster in the sun when the aircon's off than a white car. Yeah, so pay attention when your teacher's going through that point. Earlier I explained that this video here explained about how through experimentation thermal expansion results, and you get a change in volume, and therefore the density of the substance is then changed. So if you remember from an earlier chapter, density is actually the mass divided by a volume, right? So when something expands, the mass stays the same. The amount of matter in this object stays the same. So even though it expands, the mass is the same, but now you've got the same mass taking up a bigger volume. And that's when you get density dropping. So that's kind of how a hot air balloon works, right? The amount of mass in that balloon is the same. The amount of air in that balloon is the same. But when you heat it up, the air molecules get more energy, get more energetic. They go further apart, and just marginally that volume starts to increase. And as the volume increases, the density of that balloon decreases, and then it starts to float or rise. Yeah, so that's something that you'll be expected to understand. Yeah, through experiments, I think your teacher will allow you guys to, or will bring you to the lab, and you will use experimentation to figure out that if you were to heat water, for example, versus a beaker of water versus maybe a beaker of, I don't know, liquid metal like mercury, which one heats up faster? Or if you were to just put a thermometer in a container that only had air, maybe that would take the longest to heat up in your experiment. So then you start to understand, okay, a metal ruler versus a wooden ruler. The wooden ruler might be burning on one side, right? But the side that you're holding would not get hot. Whereas if you were to hold a metal ruler and to put one side under a flame, probably within a few seconds you'll start to feel your fingertips starting to heat up or even start to get burnt. So these experiments helped you to understand that different materials have different rates of heat energy transfer. Right, I've now put some extra content here. So when you watch these videos, think about the different concepts that we've talked about previously, or that your teachers have taught you, right? With radiation, conduction, convection. So it's not intuitive, for example, to think that an igloo that's made of ice can help to keep these Eskimos warm. So how does that work? Have a watch. And there's a funny video. It's basically 3 hours of this fan just going. But I have a question for you. So when you're in a hot room and you turn on the fan, you feel cool. But how does the fan actually cool you down? And does that fan in a closed room over a long period of time actually introduce heat energy to the room or take heat energy away? And the question again is, if it is introducing heat into the room, how come you feel cooler once you've turned it on? This video here, extra content again, shows you how using a greenhouse can help with gardening, growing of vegetables, increasing yields for farms, and explains how it actually works. So yeah. Oh, this video here is pretty cool. that water is actually a unique material, unique matter, not matter, unique molecule. It reacts differently to others when it heats up and cools down. So have a watch, and you help you to understand how a lot of wildlife can survive in lakes, etc., or the oceans during winter time, and how they don't all get frozen. So that's just something for you to watch, and some general knowledge. Over here I've given you guys in text a conclusion for this chapter. Have a read. I hope it was fun. Let me know what you think, and I will see you at the next one.